Welcome everybody to our new MITRExchange, which we're going to launch today. The title actually for today's series, or for today, is going to be called Safe Passage, Securing the Future of Space. And I'm joined with our guest, Matt Scholl, he's the Chief of Computer Security Division of the Information Technology Laboratory of NIST. As you know, we also operate for NIST, the cybersecurity FFRDC as well, so we welcome Matt for joining us. You all also being joined today by Gagnon, MITRE's Chief of our security operations, but also leads MITRE's strategy in the area of cybersecurity as well. So I think it was great to pick a topic that is dealing with an important problem that's facing the nation today, which is around cybersecurity, but sort of taking cybersecurity from what's happening here among us in our land, in our computers that we think a lot about, we hear a lot about, to the potential of what does that mean up in space. And as you know, for many of us at MITRE, we like sort of stepping back and looking at problems that would create some real issues for safety, and not just safety within the nation, but perhaps safety for the world. And when you think about space, globally, that's a big problem when you think about the safety of that environment and the new systems going forward. So some would say, well, why space today? And we were just talking a few minutes ago, the topic of space is big because what you're beginning to see, you are in the beginnings of an exponential growth of new capabilities that we're going to see is going to transform, I truly believe, the way we operate things here on Earth in new ways in terms of the space. You can see new communication systems, new sensor systems. It's what we coined earlier. We all lived what happened with the internet boom of the 2000 and even into the 90s. You're going to see something very similar when it comes to space. It's truly going to transform our lives in new ways. We talk a lot about 5G and how 5G is going to change things and the Internet of Things, but that is going to pale, I believe, what you're going to see in space. So because of that, and to step back, space will be this next area of critical infrastructure. So I asked our panelists to step forward and say, well, what does that mean? What are the implications then of this new environment, of this new critical infrastructure globally, and what is the role of cyber into that? So one of my first questions really is, and so to set the stage is for Matt, is, Matt, do you see it the same way, and how would you tee up this context of this problem?
So I'm going to do my best to sprinkle as many space puns as possible throughout this discussion. I think you started with space is big, so I concur with that.
The final frontier, oh, sorry.
Right. So to continue on the theme, I'm not sure what altitude we want to have this talk at, but I'll start at, maybe I'll just start at low Earth orbit and we'll see how that goes. We are in the midst of commercialization of low Earth orbit, and we see that through the commoditization and the affordability of putting items up into low Earth orbit. Everybody from high schools to undergrads are able to build CubeSats, bundle them with other people who are doing the same thing, amortize that cost onto a launch vehicle, and then send something up. So. Research, commercialization, manufacturing, you can even buy space tourist tickets now. They're on sale.
Some of us can't afford that yet.
Right, I got to see if my miles will work. So the commercialization of low Earth orbit is currently deep into effect. And as such, it's building an infrastructure of many different things, like communications was one you mentioned, manufacturing, research, ones that we're not even aware of yet, but that will emerge as the applications come out. Similar to other infrastructures, there are significant resiliency and safety issues involved. So part of the resilience and safety with all our infrastructures is, of course, the cybersecurity aspects as well. Many of the risk considerations of these devices going up are around physical, and assuring the safety and the security of launch, of establishing orbit, and of maintaining orbit. So I think we need to have discussions of cybersecurity in that context of assuring that business model, of providing that kind of safety and resiliency. Right now it's not, I'm not going to say it's not at all in the conversation, but it's not a significant part of the conversation that's occurred.
Right, right. And Gary, we were talking about that earlier in the sense of how to start thinking differently about that new environment.
Yeah,
Your thoughts?
so I think one of the differences here in the space with what's happening today is you have a lot of new players. People who don't have a lot of experience in space, they're typically businessmen who are trying to get new businesses off the ground and a whole plethora of new sensors. And I think that's the part that I think is the most significant part about what we're trying to address. You know, if you look historically at the space industry, it was a small set of players. Those players had a lot of experience in how to do launch, how to put things in orbit, and how to manage their particular constellations. This is a very different world that we're going to be living in, and I think that's really the part that I think we should put our most emphasis on.
Yeah. So Matt, let me turn back to you for a moment. So there's a role for government.
Correct.
As we talked earlier, critical infrastructure, as we know it on the ground, think of it as the power grid as a good example for that. That's not owned by the federal government, it's owned by commercial entities. And the role of federal government in the regulations and trying to make that particular critical infrastructure more secure or more resilient has always been a challenge because it's commercially owned. And as we discussed earlier, much of the infrastructure in space will be commercial going down and the influence of that. So what's your sense of the role of government and particularly NIST?
The government's role is to kind of facilitate that economic expansion, to look to how to leverage it to make our way of life better, to improve our economy, but at the same time to do it in a way that's responsible and fair so that everyone can have access, yet maintain its, again, safety, reliability, and security. While that's going on, then the other space-based organizations within the federal government are looking to the deeper issues, you know, Moon, Mars, and beyond type things, which are not quite yet commercialized. NIST has a role working with the agencies that do have oversight, because there are some agencies that do have some oversight in these areas. NOAA has an Office of Remote Sensing Licensing for licensing objects that have sensing capabilities. NASA has some control over engaging with commercial industry who is providing services to federal space operations. If you're getting food, water, supplies up to the ISS, it's going on a commercial rocket that NASA's paying for. Soon, although I'm not sure when, you know, we'll start sending NASA astronauts on commercial to the ISS as well, as then NASA starts moving out. So ensuring that quality, safety, reliability from the players who have control will be important. NIST can serve as a harmonizing and standards organization for folks who initially at least want to voluntarily build capacity, cybersecurity capacity into what they're doing. So hopefully they would cite and use our body of work as a mechanism to secure their systems and also to express to their customers and to the government what they're doing.
But do you see changes in some of those standards? Anything that comes to mind that's particular to the space environment that would be different from like the ground as you think about that?
I think there might be, and a lot of this is in areas that are more suited for folks like NASA and NOAA. There will be a blended infrastructure for some time. So for example, SpaceX will launch off a pad, and then the next one off the pad will be an NGA rocket, and then it will be commercial CubeSats, and then it will be a NASA vehicle. And so how do we share these infrastructures between commercial and potentially even high classified environments using same pads, same umbilicals, same support, yet do it in a secure and responsible way.
Requiring different security constructs.
Correct.
Gary, let me ask you a question. So obviously a lot of attention is placed on the physical infrastructure of this new domain that we've been talking about. As we create this new environment with new capabilities, and we can communicate and we can sense in new ways, data will be the real gold. Like that's the new oil of the commodity up there. And the protection of that data, as you think about that data, as it moves around and what actors could do in ways to distort or change or get access to sensitive data was a real problem. Do you see anything parallels between what we do today, what MITRE can do in that space to help secure?
Yeah, so the whole idea about vulnerability management comes to mind here. right? So what I've seen, witnessed over the last couple of years, even from the time I was actually working for a company that managed a couple constellations, there's a whole new crop of vulnerability researchers who are coming out right now trying to pick on space satellites, right? It's kind of like where we were a few years ago in the cellular industry. They're going after RF, they're going after space assets and trying to find vulnerabilities, both paid by commercial companies who are trying to utilize that service, but also on their own. And really trying to understand that space and how we get ahead of that and inform companies with responsible disclosure of those vulnerabilities so we actually get an opportunity to fix them, I think is going to be an important thing in the future.
Yeah, I want to jump on that.
Sure.
And ensuring that what is built and launched has the capacity to be fixed. This, to some extent, is the ultimate, legacy of the future. These are items that will be up for a long time, potentially burned in hardware. And so how do we ensure that they can be patched, that you can close vulnerabilities? And as we look to building next generation cybersecurity capacity, that they're agile enough to update when needed.
Yeah. And the element of that too is it's certainly the spacecraft, but it's also the ground infrastructure, because the ground infrastructure is the first avenue of attack. And I also have a kind of a pet peeve about the terminals and the terminal vendors. Sometimes they're developed by the actual satellite manufacturer, but in many cases they're third party. And they're third party being developed by a series of specs which talk about interoperability with the constellation, not necessarily with security in mind. So the ability to inject requirements into these terminal manufacturers so they understand what their responsibilities are for a security perspective and interfacing with that constellation, I think is going to have to be key in the future.
Yeah, well, Matt, you raised something which is interesting. And of course, there's a lot of hype that occurred several weeks ago about hardware that bad actors can put things on that may have some real security implications. And you just mentioned things we launch into space is there for a very long time. And are you suggesting, so this gets my mind again about the commercial operators. One, are they thinking about this problem? Obviously they tend to be more focused on, as you say, the successful launch, getting the capability up there. And is there a role here for MITRE that could help, that we could help enlighten, educate the commercial space to this very real need?
Yeah, I think so. And a lot of it is around forward projecting where these key changes are going to occur. We know that the crypto that we use in asynchronous communications will not work once a quantum reality comes around. And so how do we ensure that the encryption that's being used is agile enough so that if it is being used to secure that data, it's still viable, you're able to update, upgrade, replace type of thing. So having those conversations with those who are doing it so that they future-proof themselves rather than just living for the now type of thing.
That's great.
Yeah, I also think there's an advantage at low Earth orbit too, because unlike when we're in GEO where we do launch something, we keep it up there for 15, 20 years. That's not necessarily going to have to be the case at LEO. Right? At LEO, we might just get a couple years out of it, but then we can decommission it and be able to make some of those fixes for the next launch. Right? When you hear companies building 15 plus satellites per week, you start questioning whether we can replenish a lot faster when we're operating at LEO.
No, that's great. So look, we have 10 minutes. I don't want to eat up all the questioning time here. We also have some guests here as well. John Black and Sonia from Virginia Tech are here. Yes, excellent. So I'd like to open it up for any questions here to our two guests for the next 10 minutes or so. And if you can just raise your hand and we'll get a mic to you.
My name is Armand Mehta. I work on machine learning here at MITRE. And so I'll give you an example of machine learning, and then I'm curious about how it would apply to sort of space exploration. In machine learning, I think the average citizen is very worried about, is my car programmed to kill me? But we have much bigger ethical questions, like most machine learning algorithms, or at least a substantial number of them, are shown to be biased, sexist, or racist. What type of ethical questions are coming up in the space exploration, the technology that we're applying to it, that the average person doesn't really know exists, but we should be thinking about?
Yeah, that's an excellent question. So first of all, your car right now is already trying to kill you. Take it from the guy who drove down from Maryland. The second thing is all data sets and all machine learning is biased. The trick is knowing what those biases are, if you can, and understanding if that bias is impactful or important to the knowledge you're trying to derive from your data or your model. I think there's a promise for machine learning in kind of the air traffic control of space to some extent. I think that would be an interesting use case. If I knew what the security and privacy and social issues are of the democratization of space, I'd be probably a better forecaster than I am now. So I really don't have a good answer to that last piece.
Yes, I was going to pick up on that. So not a machine learning topic, but just an ethical topic that needs some consideration is this notion of privacy. You know, when you look at some of the future capabilities that are being talked about, a lot of them is around, I'll call it SIGINT sensing, to understand what's where, what signals are where. And that has the potential to be misused if not put out correctly, right? We could actually start tracking people much more fine-grained than we did in the past. If you're familiar with the industry at all, they pride themselves on the fact that only 10% of the globe is actually covered by cellular, but satellites cover 100% of the globe. And so the coverage is much greater in this space than it is in the terrestrial space. And that's something I think we have to take into consideration as we go forward.
It really is a huge topic. If you think about how it would transform our lives 10 years from now, and you're right, the dimension of machine learning and AI into the space domain has real implications. As we capture data, imagery, in near real time, globally, you can actually ask questions like, I can determine in the moment what's changed. I can track every single vehicle in the globe and know what's changed almost instantaneously into the future. To do that, you need some advanced machine learning and AI that's going to ingest, these terabytes of information, but that is going to come, that's going to happen. So think about the implications of that when you've got this massive gathering of data and information on our lives globally, of the world, of humanity's lives. What do you do with it? How do you use it?
And it might be mostly a bandwidth issue than anything else right now to achieve
but
it.
Quantum communication systems it's a really interesting implication from it. We think the internet is this place that captures all this information, and now add to that, create an internet in space. And now the dimensions have gone up orders of magnitude in terms of the communications, the information gathering, and the global nature of it. Like Gary said, it's no longer localized, it's global, and it's instantaneously at a global level. So it's interesting.
Imagine trading in futures with precision farming using satellite technology. You get a really good sense of what the futures would look like.
Look, Monsanto today is doing that. Monsanto is buying satellite data, giving it to farmers. Monsanto can tell a farmer, the corner of your area here needs more seedlings, or needs more water, or needs newer pesticides, or need fertilizers. It's great for Monsanto. The farmer buys fertilizer, Monsanto sells the fertilizer, the farmer grows better crops, sells the crops, so everybody sort of wins on that, sort of, unless you can see the downside of that. So there are plus sides, but a potential downside. Anyways, Peter.
Most of what we talk about today as critical infrastructure is clearly within the borders of the United States and subject to regulation and subject to decisions made through the democratic process as to what should be regulated and what should not. But space isn't like that. Something in low Earth orbit is going to go around the world.
Yep.
So what kind of thinking is being done about where this is going to have to be an international critical infrastructure, and how the United States should best deal with countries whose objectives may not be the same as ours at all?
Let me hand that over, but I will say this. I know from a MITRE perspective, we're looking at it as an aviation. So aviation is very analogous to space. Aviation's a global. Aviation cuts across boundaries, right? And that's why MITRE has such a large international presence, and the standards we set and the security dimensions of that, and airlines and the like. So there's a international set of standards that looks at globally aviation in the air in terms of safety and the like. The question is that a model that you can apply as you go up? I don't know. I'll leave it to perhaps my panelists. Gary,
I don't have a precise answer for you, Peter, but I can tell you there are international organizations that do try to look at this. The coin of the realm here is being able to get privileged slots in space. and it being a good steward of space, right? So if you are not a good steward of space, then your ability to get those slots are diminished. And so there's a responsibility for anybody who flies satellites to be sure that they're handling the satellite and using their slot effectively. So I know there's a coordination. I'm not personally familiar with it, but I know there's that coordination that happens internationally on that.
Matt, any?
Yeah, and there's also nation-to-nation coordination of the organizations within countries that have at least launch control to some extent. But it is, on the commercial side, a little bit flexible. So, you know, if you don't like the requirements in the U.S., you can always go overseas to another country, receive license there, and kind of reflag and launch. So regulatory oversight and control is potentially necessary if markets don't respond, but then it has to be normalized globally so that people don't then shop around to where things are potentially easiest but riskiest.
That's a great question.
Yeah.
Another question?
From Department of Commerce, portfolio manager. So it seems like there's this huge resource constraint, whether it's time on the pad and who gets priority or orbital slots. But I think the biggest one that I'm seeing is how we manage our spectrum. And given that international aspect that Peter mentioned, and we have people interfering in spectrums, will the standards that you're conceiving in some way take into account security for spectrum?
The answer is yes. There are plenty of spectrum management standards and standards bodies. I mean, the old standards joke is there's so many. Nice thing about standards, there's so many to pick from. And so to some extent it is slightly competitive in needing harmonization, be it, you know, ITU versus other global international standards bodies versus NTIA and within commerce. So both spectrum allocation and then the security protocols
Right, that's what
for which you secure the communication within that spectrum, that is a much more mature space being done at international scale in international standards bodies, depending on what level of specificity you want to get into that protocol security, be it in the IETF all the way up through ANSI ISO.
There's a guy who used to work for a company who was flying in GEO. That was a big topic for us because a lot of the LEOs would come underneath our birds, and if their spectrum wasn't spot on, it would blind our satellites. So the point about, you know, managing this is really critical.
And by the way, think about that, blind your satellite. So unlike our wired world, the fiber and dark fiber is buried under the ground, and you think about that critical infrastructure, how vulnerability of that and resiliency of that. Think about the space network, and you know, it's wireless. It has significant potential vulnerability. You can blind satellites, you can do funny things with the comms associated with those. So you want to knock out or create a paralysis, you have that ability. You can fly an unfriendly satellite up there. They can do a lot of unfriendly things to the communication infrastructure. Those have to be dealt with. How do you move around? How do you know it's because of someone doing something nefarious to my satellite, or I just got hit with a solar flare, and maybe it's just nature's, you know, bad things for us.
So that is another key differentiator in what we're dealing with when we're talking about space,
I
right?
was going to ask you that about you.
Yeah,
How do you know?
So, you know, there was a vulnerability research paper that was done a couple years ago from Yale, University of Colorado at Boulder, and Stanford, where they simulated the ability to take hostage a satellite in low Earth orbit that had propellant, so it was a movable satellite. They simulated they could actually get it to GEO in a short amount of time. So we can quibble whether you can get from 2 kilometers to 35 kilometers, but the point was that they're saying that if you can take over these satellites via unencrypted command and control channels to access the satellite, you can get it out of its orbit, which then leads to the next problem, and that's about space debris, right? And that whole analysis around that. So that's, to me, the future threat here, unlike we had in critical infrastructure. We don't move our grid that much. The grid is kind of the grid. Even our telecommunication systems as a fixed infrastructure, we're not moving towers around. This is a moving, flying platform that has become a critical infrastructure for us.
At the global level. Yes, Sam.
Our principal mission in the FFRDCI League is to support NIST and the NCCOE in the development of reference architectures that make infrastructure safer, more secure. What can be done, do you think, to do a better job of engaging both infrastructure owners and operators and those companies on that fly space platforms on which they're going to depend to ensure that the space segment is now included in the reference architectures that make energy, transportation, healthcare, finance, fill in the blank, infrastructure secure. How can that be done? Because that's, I think, a problem that we're going to have to solve in the next year or so, if not sooner.
Yeah, and I think there's potential for reference architectures that look at the cybersecurity of areas that can be done now. You had mentioned, the ground-based controller space is one for which best practices, reference implementations, guidance is probably sorely needed and could be used. Things around even ground-based GPS antennas and GPS receivers and how to secure them, how to configure them, how to harden them, I think is something that could be done quickly and easily and have significant impact. And then going forward, again, looking at these communication protocols. Very analogous to other types of wireless comms, but what are the best ones? Is it tunnels or packets, or depending on situations, types of things. So I think those I think are things that can be done both quickly because of the current deployment base and also have meaning and impact. I don't know if you have.
Yeah, can I just pile on that? Because I think you're spot on this, right? So in many cases, what I've witnessed is convenience trumps security, right? So what I mean by that is that I was talking to a satellite company and was asking about their connectivity to the satellite control system. And they connected their control system to their office automation system. And I'm like, why would you connect the most valuable asset you own, which is your satellites, into your office automation system? They're like, well, every now and then our satellite has some problems, and we need to be able to fix it as rapidly as possible, and so we have to sometimes phone a friend. Bring in somebody who's a more expert in that particular satellite. And they typically VPN in from their house into the satellite control system to extract the telemetry to be able to understand what's going on, to try to not issue the commands, but tell the satellite operator how to issue the commands. So what they've done is they basically created an attack vector that isn't necessarily there. And if is necessary, then what's the reference architecture to make sure that you can do that in the most secure way possible?
Because you still want to have that capability,
Right.
but how do you secure it? Because think about the power of that, being able to call in any place in the world and look at satellite telemetry.
In many cases, the best asset for understanding the telemetry coming off is actually the satellite builder.
Any more questions before one more? Okay, last question.
I've heard you mention the quantum computing a few times now. Yes, it's Wednesday. The quantum computing. Given the distances involved in satellite communications, do you think that would negate any of the benefits of the quantum computing, given that each end site would have that, yes, but you're still going to have that communications lag?
So quantum communications, potential quantum key distribution, satellite-based quantum key distribution are kind of one type of capability. I was really more referencing a quantum computer that would be able to defeat our current encryption that we're using in many of these communication protocols. So in that aspect, in the next 2 to 7 years, much of the keys and the crypto applications that are in either going up to low Earth orbit or are in geosynchronous will need to be replaced in order to not be eavesdropped because they're coming over the air and then broken by an adversary who's using a quantum capability.
Right. I mean, the way you sort of defeat the quantum computer, being able to break classical encryption, is you go with a quantum type of encryption, which is the quantum communication encryption, using basically optical links, lasers to help send the crypto keys more securely.
Yes, that's one way to do it. The other thing is we will actually have to have new algorithms. So rather than RSA, rather than elliptic curve, rather than Diffie-Hellman key exchanges, which we're using now, we need to use a new set of crypto that will be available for your both quantum and classic,
Right.
and resistant to that type of side channel.
It's a real game changer.
Yeah. The man in the middle, I think the man in the middle thing can be handled with the quantum key distribution through those optical networks. That lets you know when a man in the middle has occurred.
Right.
So you have definite visibility. You dump the key and resend.
Yeah.
We're hoping it doesn't have race condition issues. That'll be more around how good is the implementation.
Yeah, I mean, and nothing's purely quantum, so there always are things you got to think about. You have to actually implement it in the physical world. Anytime you do that, you can introduce still, as Gary would say, you know, abilities to get information, where theoretically you wouldn't be able to, but we still have to implement quantum in the physical world.
We got to bring it across.
Yeah. So and again, it's going to be an interesting space. I want to welcome. I want to thank our guest, Matt.
It's Wednesday.
It's Wednesday for attending, and Gary about the MITRExchange. We took on an important topic in this particular series today. We'll do more in the future, and welcome everybody to join us the next time. I think in 2 months on the next exchange series. So thank you.